When graphing linear inequalities, we always have to test the point after graphing the line.
Okay.
If the point makes the inequality true, then we shade that direction of the line.
So you can
Oh.
go through this.
Yeah, so on this linear inequalities, which you hopefully have seen, the lines will be dashed sometimes they're solid. The lines are crucial, but like it says up here, we're gonna have to find a point that's not on the line, because the points on the line are either going to make the inequality either true or false directly, meaning it like as though we had an equal sign. This doesn't have to make sense. We'll see it because you guys are giving me that look. Now, when we test a point not on the line, it may make the inequality false, and we are looking back at the inequality, but we solve it as though it was true. We don't really care about the inequality at that point. But when we test, we are using the actual inequality. If it's false, you shade the other side of the line. If it's true, you shade that side of the line that the point is on. Now, test a point that's convenient, meaning 0, 0, for example, because replacing x's and y's with zeros makes the calculations easy. Try not to use decimal values or fractions, because those suck and they have destroyed lives. Another easy value would be like 0, 1 or 1, 0. Have a 0 in there somewhere, but make it easy on yourself, okay? But you have to choose points to test yourself. So that's the point of this exercise right here. They've given us an equation. Are these ordered pairs going to make that inequality true or false? We'll find out. But if they were to make these true, then we would expect to be shading that side of the line, wherever that point is. Of course, we're not graphing because we're just checking, right? But again, this is something you would check at the end for testing values. So I'm gonna go to the regular equation, the negative 2x plus 3y. Now it should be greater than or equal to 3, right? But I'm gonna replace the x and the y with the x and y that they give us, which in this case, the x is negative 1 and the y is 2. Well, 2 plus 6, that's going to be 8, is greater than or equal to 3. This is true. So, since that is true, it then is a solution, which I'll just box it in. This is not really to just be like, is it going to be true or false? It is, but then on the actual graph, you would be like, all right, now I know I can shade that, whatever side of the line negative 1, 2 is, that's the side that I would be shading, okay? But let's try it with 0, 1 then. So that's a negative.
You'll show stand graphs.
So negative 2x plus 3y should be greater than or equal to 3. But they've given us new x and y values. So let's place those in there. So the x is 0. See, there's a 0 value. That's going to be nice because that's just going to 0 out. This is 3 is greater than or equal to 3. Now this one, notice that it's equal. That means it would be on the line. So this would not actually be a point that you would test. But since it's an equal part there, we would say this is a solution. If it was just greater than and not the equal part, then we would say it's not a solution, because 3 can't be greater than 3. Just understand this one would be on the line. So let's try this one too. And again, they've given us an x and a y value. So the x value is 4 and the y value is 1. If I put this in negative 8 plus 3, it'd be negative 5. Now it's saying that negative 5 is greater than or equal to 3. This one's false. Negative 5 can't be, it's not only is it not equal to 3, but it's also not greater than 3. So this one is just false all the way around. Now let's try the next one. So negative 2x plus 3y is greater than or equal to 3. Let's replace the x with 2 and the y with 3. Okay, so that's a negative 4 plus 6. Negative 4 plus 6 is 2, right? 2 is greater than or equal to 3. I think that's false, isn't it? No, that's 9. That's why you should use the calculator. No, bring it on, man.
No.
So it's 5 is great. Yeah, now it's true. That's why, again, use a calculator for this stuff.